It's got a tree on it. I wonder what it could be. It's a tree. Wow, so beautiful. Got the dark mode going. The code evaluates when you press the play button. What else could you want? But Bion, how do we navigate to other pages? Coffee break. A tree. Of course, the tree that I'm thinking of is the one provided by Material UI. Probably you've seen it a few times before on a few different websites, but basically it consists of a top-level item with a little arrow that you can expand the stuff below it. They even have a Gmail clone. Luckily, the implementation is quite simple. It's just a tree view, it's got a few attributes, and then a tree item, and you can wrap the tree items in other tree items. The question is, how do we return that array of paths into something that we can turn into a tree? Why are you coming up here on my screen and popping up and all that? So if you remember previously, we had this globby library and we have this glob pattern, which will return an array, a promise that resolves to an array of strings, and those strings are the file paths relative to this current working directory. After that promise resolves, we're going to get the paths, and then we map the paths and we replace all of the markdown extensions with nothing. And then we split by the separator. This separator comes from Node.js, but I think I might have introduced a bug because I believe globby only returns forward slashes in its paths, but I haven't checked. Luckily, I'm running in Linux, so I don't have that problem. But it would be a good thing to test in the future. Maybe I should make an issue about it. So our input is a path, let's say ABC, and then we split this into an array by the separators. So the question is, how do we convert this array into something that looks more like a tree? Well, an object is like a tree, right? Well, that's exactly what we're going to do. We're going to convert this into an object. Instead of having these slashes, imagine if I could just make this into a dot notation. Like, you know, when you have an object and you want to access A in that object, you just do object.a. So imagine instead of these slashes, we just had dots. So you can imagine what the object would look like. It would look something like this when you need the outer brackets. So if you wanted to access C, you just do object a.b.c. So how do we implement this in code? So you can see in this file, we have something called path arrays to tree, which converts our arrays of paths, which are in themselves arrays, because remember, we replaced those slashes and instead converted the string into an array of those things that were separated by the slashes. And then we take that array of paths and we use the reduce method, and we pass a reducer, and we pass an initial value. But don't worry about this quite yet, because we'll go through it a little bit later. So what does a reducer look like? It takes a tree, which is the path node. This is the initial condition of the tree. And then we have the path array, which is each one of these path arrays. And the path array consists of the path segments. And we want to convert those segments to nodes. So this is the reducer for that, which I have declared up here. Now the accumulator in this instance is going to be the node. So remember when I was saying we're on A, and then we go to B, and then we go to C, maybe we should talk about this parent-children thing. I think I've put this on far enough. I can't dodge this thing right here. It's like, why is there children in here? Well, I'll tell you why. It's because I needed to have additional data. So originally I was thinking, okay, we'll have A and then B and then C. But the problem here is we don't really have any way of including any additional data because each one of the keys in here is another node. It's exactly a path. So if I wanted to have any other data, I couldn't add it because it would have to be a path. I compromised, and instead of having this really nice clean tree, I had to have a key called children, which would specifically be used for the next node. So instead of having that clean structure, we'll now have some data here, and then we'll have children. And inside that, we'll have the next segment of the path. So now you can understand why I had this thing called page false, page true. I need that for something a little bit later, but we'll get to that. But now you understand why we have children. So back to where we were before, we were talking about traversing a tree, and this with reduce method, we were going to go through each of the segments and return the node that we are traversing to. So in the beginning, we just have a tree, and then the very, very beginning, this is just page true, children, empty. So here parent is equal to this. And then let's say for this segment, let's say the segment is A. So this looks inside children and then sees if there's a segment, which is A. This is called nullish assignment. This is from ES version. The equivalent of this is, so if the segment doesn't exist, we want to initialize it to this. But if it does exist, we don't want to touch it. And then after that, we want to return the segment that we have either newly created or the one that exists before. So at the end of all of this reduce statements, we'll have the last node in the array. And here's where the page equals true or false piece of information is important. Because let's say for that path, A, B, C, only the C part is the actual markdown file. B and A are just folders. There could be a B.md, but we don't know that for sure. So I'm defaulting page to be false for any new nodes. And then once we get to the end, we want to set it to true. So let's say if we have A/B, what will happen is it'll go through this whole process. It'll go segment to node, it'll go to A, and then segment to node, it will go to B, and then we come back here and it'll say, oh, last tree node is B, so we want to set page to true. And that way we get a tree that tells us which ones are actually pages and not just folders. Ideally, I would think that each one of these folders would have a page associated with it, but I don't know that for sure. In fact, probably during build time, I'll have something that says, oh, if we don't have pages that exist, or if there's still things that say page false, then I might throw an error or maybe just give a warning saying, hey, this page doesn't exist. You might want to create this page. I currently just can't think of any reason why I wouldn't create a page. But anyways, this is a good check for me just to make sure that things exist. So of course, we don't want to return the last tree node. We want to return our original tree. And then that passes this back to path arrays to tree, wherever that's called. So this path arrays to tree gets called and then returns that tree, and we have a promise that will eventually resolve to that tree. If you're interested in seeing how this works with NextJS, you can go and look at the code. A lot of this is a little bit confusing because it combines a whole bunch of things, and if you haven't watched every episode in this series, this might be confusing, but it's really not that important. So the main thing is NextJS somehow passes that path tree inside NextJS. We await that path tree promise, and then we pass that to our pages. How it works, not really important. So I created a dedicated path tree component inside my components folder. I have index.tsx, which you can see right here. A lot of this thing is boilerplate from Material UI. The main thing we need to look at is this path tree item component. And we pass a path, which we can ignore for now, and I'll explain that a little bit later. And then we pass the node children. Now, what does that file look like? Oh God, it's so big. How am I gonna explain this? Yeah, a lot of this is actually just to deal with this content component thing, which is a whole nother story, and it's not even worth looking into, to be honest. The main thing to note here is we have path tree item, and you can look, my code editor is highlighting it here as well, which means yes, this is recursive. And if you didn't know, this is a beautiful thing about React. You can make recursive React components. If you remember, we had let's say our tree A, and then we had some children, and then we had B, and that had some children, and then we had C, etc. Right? If you don't, go back a few more minutes that way. The idea here is we use object entries to get the keys and the values. The keys of this will be the part right here. So we'll have like stuff like this, like page, true, etc. And then we'll have children, and then that will be passed on to the next iteration. But the main thing is this part here is the key, and then this part here is the value. And in this case, I'm naming the key segment, which is true. That's the segment name. And then node is this part here. So the first thing that I'm doing is I'm creating a path from this segment, because I don't know what is before this, except for the fact that I have this property path, which is called path. So that is the parent path, and I'm renaming it parent path. And I want to append this segment to it. So let's say the parent path is an empty array. We spread an empty array over another array, and then path is A. Now the things will get interesting when you pass this path over here. On the next iteration, this will now be A, and then the new path will then be AB. So what we want to do is we want to make an href. So the href, we just need to join these paths together, make it ABC, like that. And that will be at the very end. But for example, on the first node, it's just going to be A, but on the second one, will be AB. So the next thing we do, which I'm not exactly sure if I'm super happy with this implementation, I might change it in the future, but maybe I'll just tell you the problem and you guys can come up with what you think is your own solution. So the issue is, if I left this by itself, the way that I structured my tree is that children would always have a value. Now, what that would mean is that no matter what, there would be something inside here. I'm not sure if this is something to do with Material UI or with my implementation, but what would happen is I would end up with a tree, and even the very end, even the leaves of that tree would still have icons to expand the tree. So the tree would look like this. Even though C is the last item in the tree, in other words, the leaf of the tree, it would still have this plus icon. And then when I'd click on it, it would just turn into a minus icon and there would be nothing in here. So I'm not sure if this is an issue with the tree item from Material UI. I am using Material UI version 5, so there might be some beta bugs there that need to be worked out. Or maybe this is just the way that I'm doing things. As a hack to kind of get this working, I just said, okay, I'm gonna peek. I'm gonna see, okay, does the children have anything in it or is it empty? So if it is empty, I'm just gonna return null. And that seems to work fine. But you know, this is the life of programming, especially when you're using libraries. Sometimes you have to do some weird, dirty things in order to get it working. One of the great things about software development is that you can work something out and create a solution that you think is really nice, or maybe you have some issues with, but you leave it alone for a few months and then you come back to it after a few months and then you realize, oh my God, this is terrible. Oh, I don't even touch that. And you just end up refactoring the whole thing. So you don't need to necessarily obsess about it so much in the moment, as long as you are aware that there are things that you'd like to change about your code. And then maybe you learn a better way of doing it somewhere else, or maybe you're experimenting over here and you're like, oh, this would work really well on this other piece of code. And then you can go and jump back into your project and just refactor it. It's so satisfying when that happens, because it's like you get little eureka moments and you're like, oh my God, I can make this thing way better. Maybe it's just me, I don't know. So inside my layout file, I have something called tree drawer, which will contain my tree, and we'll go look at that in the final output. Basically, it has a whole bunch of stuff. The main thing here is we have something called path tree. Now, if you remember, we had this current path being passed through. How does this thing know anything about path tree or current path? Well, that's because I made a context for it. If you want to know a little bit more about context, I have another video about that. Basically, how it works is in _document.tsx, it exports a path tree property, and that is received here by pageProps. And I have a whole bunch of higher order components. And the main thing that we're going to be looking at is with pageProps, which does exactly what you think it does. It grabs the pageProps and then provides it. I know, super boring. All right, I'll show you. Enough code. Let's take a look at what it looks like. And here we are back to the page. And if you notice, little thing in the corner, what is this? It's got a tree on it. I wonder what it could be. It's a tree. You can expand things. You can go to different pages and you can open it again. You can close it. Look at that. So satisfying. Not bad, huh? Oh, it looks pretty good. You got the little slidey thing. Yeah. Thank you for watching the video. Hopefully you guys have enjoyed it. I enjoyed making it. Whether or not you're commenting on Reddit or Discord or YouTube, please leave a comment, because you know that's how I get feedback. Oh, and thanks to the tree is so inspirational. You know, it's inspirational tree.